Hi everybody and welcome. In today's video we are going to be talking about solving exponential equations. So your goal after watching this video will be able to solve essentially any of the different kinds of exponential equations that can be thrown at you. To be honest, the skill today, not one of the easiest ones that we do by any means. A lot of moving things around. In some ways, solving with logs is a little bit more predictable, but exponential equations basically take us down three different pathways for solving. So today's lesson and today's video are going to focus on the three different paths that you can follow to get an answer when you have an exponential equation. So just a quick reminder, exponential equations and our forms. The example that we love is 2 to the third power equals 8, where we have our base, we have our exponent, and we have our answer. And then, of course, the log form of the same thing is base, answer, and then exponent on the other side of the equal sign. So our exponential form is here, our log form is here, and these are the two different types of things we move back and forth in between. So our goal in solving exponential equations is to isolate the identified variable. So if they ask for x, that's our job. We got to get x by itself on one side. Now, one of the key things to remember when we're going through and solving is that it's okay to have logs. So if you have something like, log of 7, if you punch in log of 7 into your calculator, it's a really messy decimal. It's okay to leave it as log of 7. Just remember, that's a number. So when you're going through and solving, don't think of log as a variable because it's not. If it's just log of a number, the answer is just a number. So that is okay to have in your answer. So you are allowed to have logs in your answer as long as they can't be simplified any further. So the first case is when there's only one exponential term. So you only see one of your constants with an exponent on it. And if that is the case, then we can follow these steps, and it's a little bit more of a straightforward way to solve. So we have to isolate the exponential term. Remember, isolate just means get it by itself on one side. After you've isolated that exponential term, then we just change it to log form. From there, we can solve the equation. So steps, exponent alone, change it to a log, solve. So here we have our exponential term. That was a weird color to highlight it. So here is our exponential term. We want to get that alone. So what we're going to do is take anything that is on its side and move it over. So we'll move that one over to the other side. Now that we are in this case, we can change it to log form. So just a quick reminder, we have our base, we have our exponent, and we have our answer. So when we are changing to log form, it will simply be the log of base 3 of 8 is equal to x plus 2. Now the nice thing about this is, even though it looks bigger than it actually is, log base 3 of 8, that's just a number. Now it's going to be a decimal, but it's still just a number. So because that's just a number, we're happy. We can now deal with our x, and we can get a final answer here. So subtract 2 from both sides, and we'll be left with x is equal to the log base 3 of 8 minus 2. Now, again, like I said, this is a number. All of this together is a messy decimal. I personally don't like rounding. If your math teachers in the future do, punch it into your calculator. It's that easy, it just gives you a number. But for now, for this course, I'll say just leave it there, and we are good to move forward because that is our final answer. So the second example here, similar setup. We still have to get our exponent alone. So anything that's not that exponent still, we are going to move to the other side. And then this is the tricky one because we have 3 in front. 3 is a constant. That's 3 times 2 to the y power. We still have to move the 3 over. So anything that we can move over, we must. So because of that, we do have to divide both sides by 3. So 2 to the y power is equal to 7 over 3. Now notice I did not put that as a decimal because of all the repeats and rounding. We don't like rounding. It makes things less accurate. So I'm leaving that as 7 over 3. So from here, just like before, base, exponent, answer. We can change this over to log form. So log base 2 of 7 over 3 is equal to y. And just like that, we have y equals, and we have an answer. So for both of these, we're going to see messy decimals, and that's okay. We can just leave them in log form, makes things a little bit cleaner, and actually more than just cleaner, makes them more accurate. Every time we introduce rounding, we introduce a degree of inaccuracy. So there are the two answers there. For method 2, if we have more than one exponent, so in this case, exponent with the variable in it, in that case, we need to make our bases the same. So our first step here is change the base to equal each other. So bases must be the same, and then from there we can solve the equation of the exponents. So once the bases are the same, all we do is just take whatever is in the exponent and we solve that. So this can be a little bit tricky if you don't see what the common term is right away, but all you can do is just break things down and hope for the best and see if it works out. So if we have something like 8 here, we can break 8 into 2 and 4, and then 4 into 2 and 2. So for 8, we have 1, 2, 3 2's. So we can change 8 to 2 to the third power because we have those 3 2's. So we have replaced in parentheses 8, we replaced it with 2 to the third power. The x minus 1 is still there. 2 to the x plus 3 power is also still there. So from here we can just solve. So we take whatever is in the exponents and we can set them equal to each other. So the x plus 3 and then that 3 times x minus 1, both of those we can solve now. And be careful, this 3, it does go to both terms. So it is going to go to both of those terms. So from here, distribute in 3x minus 3, then x plus 3 on this side, and then move our x over, move our 3 over, divide by 2, we get x is equal to 3. So again, from this one, just breaking down our terms and seeing what we have here. For the second example, this is just a little trick from Algebra 2. If you have anything on the bottom, it is whatever that thing is to the negative first power. So 1 over 9 is the same thing as 9 to the negative first. That works for anything. So anything on the bottom, the way that you bring it up, as long as there's just a 1 on top, just bring it to the negative power. So in this case, our first term, 1 over 3, we can just replace that with 3 to the negative first. And then the x is still on the outside. It doesn't help us because 3 and 9 aren't the same, but if we think back to 9, if we break down 9, this 9 right here, we can break it down into 3 times 3. So we can replace that 9 with 3 to the second power because there are 2 3's. And then just be careful because x squared plus x is still on the outside. So going through, our bases are now the same. So we can now take just the exponents and set them equal to each other. So negative 1 times x is equal to 2 times x squared plus x. Just like the other example, be careful. This 2 does distribute to both terms. So always remember that. If you're changing anything on the inside of those parentheses, it will distribute to each term in your exponent thereafter. So minus x, 2x squared plus 2x in this case. And then from here, bring all the variables to one side, and then we can start solving. So always a key, if it looks a little confusing like this one, all the variables on the same side, and things will start to work themselves out. So we'll move this x over. So I'll have 0 is equal to 2x squared plus 3x. And then from here, we actually have to do a little bit of factoring. Now this one's a little bit of a weird one because we have x squared, but we don't have a constant, so it's not a quadratic. Or not, at least not something that we can factor, I should say. So we're not going to be able to factor using the box method, but we can use Gcf factoring because they do have something in common. So if any of the terms ever has something that they share, you can always remove that. So in this case, we can change it over to 0 is equal to x is what they both have in common, and then times 2x plus 3. So just reducing each term by the value of x and keeping the x just on the outside. So from here, we can use the zero products property and set each of our terms equal to 0. So x is equal to 0, and then 2x plus 3 is also equal to 0. So for here, subtract 3, divide by 2. So x will be equal to negative 3 over 2. So the two answers that we get for here are 0 and then negative 3 over 2. So both of those work. So just things to keep in mind as we're going through and solving. And remember, we don't like to divide by any of those variables. We don't want to lose any of our roots. So just an important aspect to remember every time you go through and solve. And just a little bit of a trick here with the Gcf factoring. Comes up sometimes, just a good thing to remember. All right, so the last part that we have here is, to be honest, the most challenging part is when there's more than one exponential term and the bases are not able to be made the same. So in this case, we can't equalize those bases. We can't just set our exponents equal to each other and solve. So basically the idea is we have to turn the exponential into a problem with logs. So this is where logs come in to help us solve. So you take the log of both sides, and you can choose your favorite base, whatever one you like. I like to use just common log base 10. One, it's less things to write down. You don't have to write the base down, but two, 10's a little bit of an easier number to work with sometimes. Second, we want to bring down our exponents. And then third, we can distribute and gather all of the terms with an x on one side. So just like we did in the example above, anytime you have a variable, get all those variables on the same side and try to get them alone. Factor out an x, just like we did above. So again, we saw that they had an x in common, so we can use that to our power. We can factor one out, and then from there we can solve for x. So here's going to be a bit of a new skill. Everything before we've kind of seen at some level in Algebra 2, but for a lot of us, taking the log of both sides is going to be something a little bit different, a little bit newer. So in this case here, quite literally, you just do the same thing to both sides. You write down log, and by writing down log, you just put whatever's in the equal sign just inside of the parentheses. That's it. So we just recopied 3x, we recopied 5x plus 1. That is all. So because we did log to both sides, this is allowed. This is okay. And from here, the next step is bring down the exponents. So whatever these exponents are, we can use our power property from last week, and we can take that blue term and just bring it out front. So again, the blue terms, we've just moved them out to the front. In this case, distribute is step 3. So if you have a parentheses, we actually do need to distribute the log into both of those parentheses. A little bit weird, but basically just keeping consistent with getting our terms together. So for our first one, we're already good. Nothing to distribute. But for the second one, we'll have x times the log of 5 plus sign, and then 1 times the log of 5, or just the log of 5. So by doing this, what we've done is we've eliminated parentheses. It makes things a little bit easier to work with, and now we can start to move parts around. So for step 4, it says we should, or sorry, we didn't even finish step 3. So we did distribute, but the second term is we have to gather all of our terms with an x on one side. So let's highlight these x's. There's 2 of them, so we've got to get both of those green friends together. So we can subtract this. And what we'll be left with is x times the log of 3 minus x times the log of 5. And then we just have just the log of 5 on the right side. So now we can factor out an x. So each of the terms on the left have an x in them. So we can do x, and then the log of 3 minus the log of 5, and that's all equal to the log of 5. So from here, we have x times something, so the way that we bring that over is with division. So the log of 3 minus the log of 5. And as long as we do that on both sides, it does look a little bit weird, but it is allowed. This will simplify, and we're just left with x is equal to the log of 5 over the log of 3 minus the log of 5. Now that looks like a lot, but remember, that's a number, that's a number, that's a number. If you punch all of those into your calculator, it'll get you messy decimals, and that's okay. So just something to remember if you ever have to do that in the future, if you're looking for a value, at that step you can plug everything in, not beforehand, but our fully perfectly accurate answer without any rounding is written just like that. So just a little bit of practice there as we're going through and solving these. I think it might be beneficial just to do our last one and just kind of take a look at one more example here. And then hopefully with 6 practice examples done in your notes, we'll be in a good position to be successful for practice questions and for any assessments we take on this. So step 1, log of both sides. Step 2, we want to take our exponents and bring them out in front. Step 3, we want to distribute our log into our parentheses here. And then the second part of this is gather our terms together. So we want to move all the x's to the same side. And then the next step is make sure it's just x's alone over there, so we do have to move our log 4 over. And then now from here we can factor out our x. And then from here, anything that's not x we can divide. So that simplifies, and we're left with x is equal to. And remember, all of these are just decimals. And we have a final, messy, but a final answer with x by itself. So that's our challenge. Again, when we're solving these, is just to get x alone. So a bit of a complicated question here on those last two, but hopefully the first couple are a little bit more straightforward. And the best thing that we can do, especially when these skills are challenging, is just to practice. So that's our only new skill for this week. So hopefully that'll help a little bit with our flow of information. It's a big one. So we'll make sure that we dedicate some time in class tomorrow as well to practicing. As always, thanks for tuning in, everybody.